We're carrying on with this halogen sheet. So chlorine is bubbled through an aqueous solution of potassium bromide until a color is seen. So chlorine, bromine, iodine. Too reactive in the lab. This is the most reactive or strongest. So if you have potassium bromide there and you add chlorine, now what did we say about chlorine? We said no, and then we said fluorine, bromine, iodine, astatine, but we're interested in these. These are, they run around in pairs. They run around in pairs in the real world. They are called diatomic molecules. Right, so you should know this. Most reactive, least reactive. Now, so that goes around in pairs. So when these two react, chlorine's tougher than bromine. So that's going to get moved. And chlorine's going to go there. And then bromine's going to work its way there. Ignore that too. All I'm showing you that because chlorine's stronger, more reactive than bromine, they swap places. It displaces it. So we need to write that here. So we're going to add chlorine to potassium bromide. Now the question is, so why is it, let's write here, why is it potassium bromide and not potassium bromide? Because we know potassium forms a positive 1 ion, group 1. Bromine forms a negative 1 ion because it's group 7. So plus 1 minus, because they're both the same, not sign, but the size, they're both 1s. We can ignore them. That's why you end up with potassium bromide that way and not that way. So because bromine gets kicked out, you end up with potassium chloride plus bromine. So we know bromine runs around in pairs, so we need a 2 there. So we've got 2 bromines. We've only got 1 potassium here, so we need a 2 there. Now we've got 2 potassiums, but we've got 2 chlorines here. So we've also got 2 chlorines, so this is fine. So the equation looks something like this. Get rid of that so it doesn't cause confusion. There you go. Right, explain the reaction that occurs. In your answer, refer to the final color that causes the final color, the type of reaction, and relative reactivities of the two. Right. This is now in the solution because aqueous just means it's dissolved in water. So you put AQ. We know that that's gonna give a it's in water, so we have to call it yellow orange or orange. Orange, yellow, orange. It's not quite brown, so they will not allow brown. That's interesting. Add orange bromine water. So remember, that's how we've learned it, and we add orange bromine water. So we could put that the solution is going to be orange in color. You can put a light yellow, a light orange can be mistaken for a yellow. So it depends on the concentration, I think. So they'll allow you to get away with yellow. Right, what's causing that is the bromine. What sort of reaction is it? It's a displacement reaction or a redox reaction. Because something's gaining. Remember we said oil, rig, oxidation is loss of electrons, reduction is gain. What happens here? Chlorine gains electrons and bromide or bromine, when it's displaced, has lost an electron. So that's what's going on. And the relative reactivity, so we said that means that chlorine is more reactive than bromine. So we need to write that down for 4 marks. So we've said everything. We just need to write down. So the solution turns orange. Let's just stick to that. Why? Because the bromine is in the aqueous solution. In the has become it's bromine aqueous. I think that's it. Right. What type of reaction is it? You can say it's a displacement because bromine has been displaced, and it's a redox reaction as well because bromine's gained. No, bromine's lost. Bromide has lost an electron to become a bromine atom and then a bromine molecule, and chlorine has gained an electron to become a chloride ion here. So we can say it is a redox reaction. Right, and the final thing we need to say we know is that chlorine is more reactive than who? Than bromine. Why? Let's just put it in there anyway, because chlorine displaces bromine. Chlorine displaces bromine. Done. Right, let's keep moving on. Where are we? Right. Chemical tests can be used to detect ions in solids and in aqueous solutions. A solid produces a gas when heated with sodium hydroxide. Damp red litmus paper is turned blue. Right. That's ammonium. So it's ammonia gas. So ammonium. Because it turns damp red litmus paper blue. You heat it with sodium hydroxide. Right, okay. That's one of the tests. Dilute nitric acid is added to aqueous solution followed by silver nitrate. So silver nitrate is for halogens. So think of it like as a silver silver halo. So silver nitrate for halogens. You've got fluorine is too reactive. We don't use that. We use chlorine, bromine, and iodine. We have a white ice cream with a hint of lemon, which is yellow. So we've got a yellow precipitate, so it'll be the iodide ion. If you add dilute hydrochloric acid, you get a gas. It's going to be CO2. It'll be carbonate because that will give off CO2. Remember the ores, ores, corks, and mash. So you've got alkali acid gives water and salt. Base and acid gives water and salt. Carbonate and acid gives water, carbon dioxide, and salt. Metal and acid gives salt and hydrogen. So here and here we're expecting bubbles. What's another name for bubbles? Effervescence. Let's move on. Sodium hydroxide is added separately to 3 solutions. Copper, iron, iron. So copper is a blue policeman. Blue. Iron 2 is green. Green. How do you spell green? Green. And iron 3 is brown. Right. So copper 2 is blue. Iron 2 is green. Iron 3 is... Oh, okay, what am I doing? So it's blue, green, brown. Blue, green, brown. Oh, it's this one. See, I was a world of my own. I was making my own stuff up. Right. So copper 2 is green. Iron 2 is... Copper 2 is blue. Iron 2 is green. Iron 3 is brown. Oh, what's going on? There you go. Let's move on. When barium chloride is added, white precipitate formed. Barium chloride. Okay. That is to do with a carbonate. Whoa. Right. My screen went off for 1 second. I don't know. Oh my god. Whoa, dude. Right, quickly get this done before it goes crazy on me. Right. Barium chloride is added to an aqueous solution of a compound. A white precipitate is formed. Then a color solution forms. Right. That is for a carbonate. Barium chloride solution. Right. Let's move on. We can discuss that later. Right. Bromine, chlorine, iodine. Right. Elements can be obtained by electrolyzing molten halides. Okay. For group 7. We just need anything there. Elements with paler colors are lower down the group. That's not true. They get darker. Boiling points, gas, liquid, solid. They decrease. No, that's not true. Elements form covalent compounds with other non-valence metals. That's true. Their molecules contain 2 atoms. Yes, they are diatomic. All gases are no, that's not true. Now, the elements can be obtained by electrolyzing molten metal halides. Sodium chloride, yes. Yes, you can. So it's these 3. So the way I worked it out was, I know fluorine, chlorine, bromine, iodine. At room temperature is gas, liquid, solid. So from there I figured that one out. And I figured that one out. So we eliminated those 2. right? They form covalent compounds with other non-metals because it's a non-metal, so that makes sense. So that got eliminated in effect in a positive way, right? I know that they're diatomic, so that got eliminated. So then we just had these two. The elements with paler colors are lower down the group, but I know that I learned the colors as you greedy red brown fox wearing an orange high vis jacket jumping over a grey fence chasing a purple chicken. Right, purple, and that is orange. So this is for vapor and this is for vapor. So we've discussed this before. So I know that they're not, so we eliminated that one. Now with this one, if you know about electrolysis, you know, do you know when you electrolyze sodium chloride, come on, when you electrolyze sodium chloride aqueous, or even, no, forget that, that's the more harder one, sodium chloride, which is a solid, and then it becomes a metal liquid, it becomes molten, sorry, liquid. You end up with sodium metal at one electrode and chlorine gas at the other one. So that's how I eliminated those, but you can try maybe just learn them off. Right, there's something going on with the monitor. Right, let's see if we can get through this session. Group 7 elements are called halogens because they react with metals to form salts. Yeah, halogen means salt forming. Write a chemical equation, potassium iodide from a metal and a halogen. So potassium is a metal and halogen is iodide, so it'll be iodine. I know iodine is diatomic, so that's why I've got this 2 here. And then it becomes potassium iodide. Potassium iodide. I know that forms a -1 ion, this forms a +1 ion. So because they're both ones, I'm not worried about the signs. It becomes potassium iodide. Now I need to balance this. I've got 2 iodines, so you've got, I need to put that there. So I need now I need 2 potassiums here. That's it, done. Right, the equation for reaction between hydrogen chloride is 2HCl. At room temperature, hydrogen chloride and hydrochloric can be both. Come on, don't do this. Oh dear. Right, that's not a problem. At room temperature, hydrogen chloride, I'm going to have to finish here. I think I need to see if I can get through this question. So hydrogen chloride is a gas at room temperature and hydrochloric acid is aqueous in solution. Let's see if we can do this. Right, you put magnesium, magnesium reacts with what? Hydrogen chloride is dissolved in methyl. Methyl benzene is an organic solvent. It does not dissociate hydrogen chloride to form hydrochloric acid. So there's no acidity, there's no hydrogen ions floating about. So when you put magnesium and you put a metal in, there's no reaction, there's no effervescence, there's no fizzing. Right, however, when you add water to hydrogen chloride, right, you end up dissociating this, so it becomes hydrochloric acid. And that is acidic. When you mix it, a reaction occurs, you get effervescence. Effervescence. Let me write it properly. Effervescence. Right. That's just another word for bubbles. Right, once you've got bubbles, right, explain the observation. Effervescence is bubbling. So come on, try to get through this. Right, something moved. It doesn't matter. We'll explain the observation. So we can say we will see effervescence or bubbling since hydrogen gas is formed when magnesium reacts with hydrochloric acid. You also see that the magnesium ribbon will disappear or get smaller. Will disappear or get smaller. Right, okay, let's move on. Oh, there's loads more. Halogens can take part in displacement reactions with halides. Right, halogen solution is bromine solution. Come on. No. Okay. Bromine reacts. So remember, fluorine is too reactive. So you got fluorine, bromine. No. Let me start that again. Fluorine, chlorine, bromine, iodine. That's normally too reactive in the lab, but it's there. Chlorine is the right. Reactivity goes down. So this is the most reactive, and this is the least. So you got bromine reacts with iodine, so it'll kick it out. A displacement reaction occurs. Chlorine cannot displace its own halide because look, chlorine and chloride. Iodine is less reactive than chlorine, so it cannot displace chloride or chlorine from there. Explain which test gives a result that cannot be used to compare the. It's test number 2 because a halide, or you have to say rather than making it generic, chlorine in this case, chlorine can't displace or react with chloride ions or cannot displace itself. Okay, right. Come on, last bit. Ooh, come on, let's get through this. Right, okay. Which observation shows the displacement reaction occurs in test 1? Test 1, right, you're going to get a color change. So what color is iodine? Right, you've got, yeah, okay. So what's happened is add orange bromine water. When you when iodine is displaced into the solution, it will become darker because remember, as you go down the group, the colors get darker. So it was bromine water, and now it's iodine water, so we expect it to be darker out of these. Look, there's no effervescence, nothing purple, no white precipitate. Astatine is the last one in the group 7 halogens. So chlorine gains 2 electrons to become 2 chloride ion. Astatine loses 2 electrons. That's why you've got it on this side here. You can have it on both sides, but if you want it as a plus, it's here. Becomes an astatine molecule and releases 2 electrons. Write an ionic equation for this displacement reaction. Right, so we put it all together, we say Cl2 plus 2 astatines gives astatine plus 2 fluoride ions. Right. Explain with reference to the appropriate species and to electrons why this reaction is described as a redox reaction. Right. Chlorine is reduced. Why? Because it gains